Let's explore about deep learning and neural networks. So deep learning is a field of machine learning which deals with training deep neural network. So here you see the term neural network. So what is a neural network? So in order to gain some intuition about neural networks, first let's look at an example. Let's say you are predicting some price of house and you are given some data. And let's say for simplicity, we are dealing with just one variable. So here the variable is size of house and the output is price. So if these are the different prices for size this, price is this, similarly for other points. So it may look simple and you may think that a simple linear regressor will predict the price. So you can draw a straight line passing through these points. So now we can have other constraints like the price cannot be negative. So it will not be like this, but instead it will be like this because price is greater than equal to 0. And this shape has a special name, this function. This is called ReLU function. And it's defined like this. If x is greater than 0 or greater than equal to 0, then take it x, otherwise take it 0. So we will use this a lot in this course on neural networks. So this simple linear regressor is itself a simple neural network. So here the input is size of the house. Then in this case, there is a neuron, artificial neuron in this case. So this artificial neuron takes the input size and predicts the price of the house, which is y in this case. So this is the simplest neural network, which consists of just one artificial neuron, and because it takes one variable and its output is 1, and a linear model fits here. But the life is not so simple all the time. So let's say instead of depending on just size of the house, there are some other factors also. So let's say this is the neuron that predicts price or y. And let's see the direct factors that affect the price. So let's see the direct factors that affect the price of the house. One of the factors can be family size. So the bigger the family size, you would like to purchase bigger house and the price should accordingly be higher. Other factor could be the locality or the nearness or neighborhood to supermarket, schools, hospitals. So if these are nearby in the locality of the house, then it's most likely that price would be higher. Then other could be appreciation or depreciation. For example, if it's in a good locality, then its price will not depreciate. And another factor could be that if the house is new or if the house is old, then it will depreciate quickly. So this family size may further depend on, it will determine whether the given number of bedrooms or size of the house can fit this given family size or not. So this is x1, this is x2. So you see that these two determine whether a family size can be fit or not. Similarly, there can be a factor, zip code or locality, which governs whether there are schools or hospitals or supermarkets nearby or not. And then this zip code also determines the depreciation, future depreciation. If it's in good locality, then its price will not depreciate that much. And then next factor can be the condition of the house. or age of the house. So you see that we have these 4 factors, and these determines these 3 factors which directly govern the price. So here you see that not all of these are connected to all of these nodes, neurons in the next layer. But you don't know this beforehand. This is a simple example, so you can relate here that family size, it depends on size and number of bedrooms, whether it can accommodate that family size or not. But in complex problems, you may not know the exact relationship, that this depends on just these x1 and x2 and not these x3 and x4. So it's the job of the neural network to figure out that which of these input factors are related to the next neuron. So what you will do is that you will define a neural network. So you will think that this is a not so complex case, so maybe 3 layers should suffice. So you define these 4 factors. These are your inputs. So you will have a data set where you will have x1, x2, x3, x4. And then you will have y, the price. So you have a bunch of data, thousands of these, and also the output price. So this is called input layer. This is called output layer. And anything in between is called hidden layer in the neural network. So you will think that maybe for this case, 1 hidden layer would suffice. So you define 3 neurons here. And every neuron in the previous layer is connected to every neuron in the next layer, because you don't know exactly which of these factors are related in what way. What you give is just a bunch of data to this neural network, and ultimately it will figure out that maybe this and this govern a factor, and then this is highly govern this factor, and maybe this and this control this factor, and these 3 are directly controlling the price. So these will get a very high weight. So these weights you will initialize randomly, but based on this abundant data, it will try to figure out that this weight should be high and these weights should be very low or close to 0. So ultimately the network will learn that these are the solid edges, and there may be some small weights to other edges also, but these are mainly governing the price of the house in this case. So this is a basic notion of neural networks.